Thank you. Thank you very much. First of all, I would like to thank you all for being here, because I know that currently there are two other very important talks being given at the same time, so I guess that everybody that's here is interested in this topic. Okay, so first of all, I would like to tell you a little bit about us, okay? So who are the people at Datatones, okay? We're nerds, okay? We all started working in big data for international companies, and at some point we decided to found our own startup a couple of years ago. What we did is find people that were working in related technical fields, but also, at least from my side, it was also people that could manage things like, running a business around. So that helps a lot. And since then, we've been participating in different Hadoop projects, okay? But this, so basically, we're all coming from a technical background. What are we going to do today, okay? I'm going to talk about moving Hadoop clusters around, okay? First of all, we'll see why do we need to do this. Secondly, what are the challenges that we face when we do this, okay? And given those challenges, what are our options for overcoming them, okay? What are we going to do to successfully end these projects? So, great ideas start in a garage, okay? We all start small. Why do I say that? Because, big data is a new trending topic. It's the new cool thing. Everybody's going into big data. We have a full conference around us related to big data. So everybody wants to jump in. But of course, they want to minimize the kind of costs that are associated with having a big data platform. Some people here are talking about multi-petabyte scale software and clusters. But if you're just starting with big data, you may just want something cheap, go to something like the cloud, just have, I don't know, a proof of concept. So even if you're aiming for, like, I want to have Batman to save me, to handle all my data, well, you do end with Batman, a rather, more neighbor version of Batman, okay? So you do start with big data, but you're still, in the beginnings of that. So at some point, you may decide that you want to move, okay? You set up your cluster, it's running, you're into big data. What would you like to move? I mean, after all, even if you started as a proof of concept, the software is scalable enough. You should be able to, just keep going and add more data to that. And so why move? Okay, first of all, costs. We all know that the cloud has no upfront costs, so it's very easy to start. There's no barrier to entry, but at some point, the costs begin getting a little bit higher as soon as you make heavy use of that, and you may want to reduce that. Okay, you may either want to move to a different cloud provider, you may want to move to an on-premise installation. Also, performance. Okay, maybe you started with something that was very cheap, you have machines that were not dedicated. We all know that the public cloud shares a lot, and you may find that at some point performance is not what you would expect or what the end users expect from you. And then you want to go somewhere that you will try to find that performance. Third, well, corporate policy. Someone comes and says, hey, we don't want anything in the cloud. I don't know. We want to consolidate the data center. We want to build a data center with dedicated people, let's say, for example, in Spain. I mean, and that's been happening, okay? So they want to get rid of all the external costs, all the things that, are scattered all around the place, and, just consolidate into one big data center in one central location. And finally, for legal reasons, okay? You may find yourself trying to ingest some data that you're not allowed to copy elsewhere. Let's say, for example, that you start with a cluster in the United States because it's cheap, because there are many vendors available, but then you need to ingest some kind of personal data, okay? personal data by law, European law at least, is not allowed to, or certain kind of personal data is not allowed to be, freely copied elsewhere. So you may need to move that back into Europe just for that. So what are the challenges? I mean, okay, so you have a cluster, you need to have it elsewhere, just copy it. It's simple, right? I mean, it's a procedure that's been done since the beginning of the IT industry. However, we're getting to the problem with big data, okay? We have very big volumes of data. Network speed is also very good, but not as good as the rate that we increase the amount of data that we store. Okay, so let's say, for example, that you have a 20 terabyte cluster, okay? That's not a big cluster by today's standards. I mean, if you go elsewhere here, as I say, we're talking about, bigger things. But let's say that we're talking, you still have the, neighbor Batman. It's still small scale, but you want to, move that 20 terabytes. If you go at 10 megabytes per second speed, and that's megabytes, so in terms of network speed, that would be a 100 megabit link to serve that. If you want to copy all that, it will take approximately 2.5 days. Okay, that's a lot of time, especially if you take into account that you're supposed to have a dedicated link, which you probably haven't. I mean, you probably need to think that someone else in the company is using that internet access for something. And also, you have this problem with the Hadoop, basically, because it's a complex software. It has many roles. You have to do many things. So it's difficult to see how you could move that around, okay? So, okay, we want to see how we can copy that. Let's explore our 4 options, okay? I'm sure there are many more, but these are the first 4 that we could come up with and that we've seen. First of all, we have the classic Linux approach. We'll see more about that. Amazon S3, using that. DHCP, okay? And finally, we'll see how about extending Hadoop. Classic Unix methods. For those who don't know, this is a photograph from the, I think it's from the 70s, something like end of the 70s, about the, Unix, one of the first Unix installations. So we're talking about technology that's been around for some time. Okay, you have these traditional file transfer technologies already in place. You have FTP, SFTP over SSH, rsync, NFS. Okay, it's been used elsewhere. I mean, if you've ever migrated anything, this is what's been used. So why not go ahead with that? Sure, let's just try to build that. What will be the procedure? And if you ask, I mean, if you compare that to any kind of procedure, I don't know if you migrated your relational database or something like that, you will find that it's something very similar to this. Okay, you just install new software at the new location. Okay, stop the platform. Here comes the difficult part. Why do you stop the platform? Because if you are with a platform that's being used, be it Hadoop or be it whatever, and you're still making changes to that, okay, you need to, of course, have a way of checking what the changes since the beginning of the copy were, okay? We're talking that you still don't have, if it's early Hadoop installation, you're probably not up to that point. And even if you were, it's difficult to track those, okay? So for consistency, you just stop everything. You know that no changes are being made and start the copy, okay? So you need to copy the data from the old platform to staging. What's staging? We'll see in the next slide, but basically you need something that's related to the Unix world. This is just still just Hadoop, okay? Then you copy the data from staging to the new platform, start the new platform, test, and you always need to include a rollback procedure, okay? Hopefully you won't need to use it, but just in case something goes wrong and you need to go back to where you were at the start. So why do we need to set up the staging area? Basically because Unix only understands about files, okay? So it needs to have a way of accessing that Hadoop information. So Most of the times, you just have, I don't know, cabin, NFS server, file server, whatever. You just download the data there, even using, just HDFS get, put it into the staging area, and then you just copy that to the end platform, okay? As you can see, we need to do a double copy here, okay? And that's an issue because we double the transfer times. Sorry. First of all, what are the advantages of this, okay? Every sysadmin knows how to do this, okay? If you ask anybody that doesn't understand Hadoop or, but it's been in the IT industry for long, they will tell you something very similar to this. This is the kind of procedure that we're doing. While we're at it, okay, this is something very common in projects, especially in Spain. In Spain, it's called apoyaque. Pues ya que estamos, ¿por qué no aprovechamos y hacemos 3 cambios más? Okay, what does that mean? Basically, it means that, okay, we weren't able to touch this because it was production. Now we're beginning to do some changes. Why don't we do all this list? And they present you with something like this. It's like, okay, let's just say that it's like secondary goals that may at some point become, the primary goal of the transition. At this point, with this kind of technology, what you can do? You may redesign your platform from scratch. I mean, you're just rebuilding everything. So you may as well profit from that and, I don't know, go to a different Hadoop vendor or something like that. Disadvantages of this, it needs a big staging area. Okay, we're talking that we have this staging area in between, so you need to have something where you can copy big volumes of data there. Okay, and you need to set it up so that it's able to cope with all that you're going to do. Server-to-server copy. Okay, since we're back to UNIX technology, you're just going to one server and copying to the other. Okay, that may cause performance issues. If you need to do something in parallel, you probably have to coordinate it yourself. It may become a bottleneck at some point. As I say, it's probably mostly a management thing. I mean, you have to make sure that everything's running manually. Also, very important disadvantage. We're talking only about files. See that we haven't spoken yet about any other Hadoop services, okay? As we know, there are many others in place. But the big problem here, as we said, is mostly the data, okay? You need to copy the data around. But what about the others? You need to copy them separately, okay? Total downtime, as we said. You stop everything, copy, and then start. That may take several hours or even days, okay? If you have bigger data, I mean, if you do a quick calculation and that takes, I don't know, let's say a week or two, don't even try this, okay? This is just for very small installations. Second option, okay? Let's just use Amazon S3. Why? First of all, it's a very cheap alternative. It's readily available as well. So remember that we talked about setting up this staging area. Here, you don't even have to do that. You may just, go ahead and use it from the very beginning, okay? What's the difference here? The procedure is almost the same. Instead of talking about a staging area, we talk about S3. You just use it as that, okay? Also, remember, always include the rollback. Advantages. Pretty straightforward. I mean, it's very similar to what we did before. You just use S3. You don't even need to prepare for that, okay? Well, we're at it, okay? What we may do, I mean, you're copying data to Amazon S3. If you plan to use Amazon S3 at some point, either be because the destination platform is already Amazon, or you want to have some S3 copy of your data for whatever reason, this makes sense. You would have a copy of your data at Amazon S3, and you can plan for something else. Disadvantages. We need to set up an AWS account. It's a very small disadvantage, we all know. I mean, probably everybody in the room has one. Also, transfer times and the double copy. Double copy in case that you're not going to Amazon, okay? If you're going to Amazon, then poof, it's already there. Third option, DistCP. DistCP is a technology that was created for copying data between two different clusters, okay? It's native to Hadoop, Okay, so now we don't need the staging area. We're just copying data from one cluster to the other. Okay, also, as you will see from the picture, basically this CP is optimized to, move from many servers to many servers. Remember that we talked that in the standard UNIX methods, if you want to parallelize that, you have to do it yourself. Here, it's already being taken care of by the own Hadoop cluster, okay? So you have a very high throughput, okay? You may have more throughput than you want. I may need to, tune it down a little to be able for everybody to have internet. What's the procedure? Reinstall everything at the new location, okay? Stop almost everything, okay? Why not everything? Because basically, right now we need a couple of Hadoop services to be around to be able to do this, okay? HDFS and Yarn. So you just stop from the top level of the stack down to that point. Then you copy the data from the old platform to the new. And as we say, hopefully it will take less time than if you do with the Unix methods. Start a new platform and test. And, okay, that's a mistake. I've been rickrolled. But don't worry, I will remove that from the final slides. Advantages of this, okay? It's native to Hadoop, okay? We get rid of the staging area. Why did we need a staging area if we can have something like this, okay? And we have very high transfer speed. Disadvantages, we're still talking about copying data. So we're moving HDFS data around, but the servers still need to be set up in the final location. You still need to do some manual job. It's still human error prone because you may at some point install something different that was on the initial cluster, okay? Also, clusters need to be connected, okay? Why? Basically, because we need to have private network connectivity between the two clusters, okay? They need to be able to be routed between them. You can do that via, just set up a VPN, and voila, you're done. Also remember to include something like a, global DNS that has all the entries for both sites. Or you may even resort to NAT, network address translation, if you're using web HDFS, okay? Then you don't need to set up the VPN, but it's a little bit slower. So, very important point here. If you have something like a secure Kerberos cluster, that will complicate things a little, okay? Especially because we're talking about two clusters here, two different clusters. Depending on the way that you set them up, it may be very easy or it may become quite the nightmare. I mean, on the VerdSCP page, there are, the different use cases that you may find are already there, documented, but it certainly complicates things a lot, okay? So that's something to keep in mind. As a side note, okay, remote access. We're talking about copying files here, but that doesn't mean that you just have to, copy everything raw, okay? Remote file systems can also be used in different, Hadoop parts outside this CP, okay? For example, as location for Hive tables. While we're at it, Pojake, why don't we transform the data? I mean, at some point, you may need to consolidate all your data. You may have text, you may have, I don't know, Flume, small files being left. You may have anything that you need to consolidate. I mean, you may go to these formats, org or Parquet, for performance reasons, for query reasons after. So you may do that at this point, okay? You may just, instead of copying the raw data from one table to the other, you can just transform it using a query. Once again, and this is really the important question here, is this the right time? I mean, what's the goal of your migration? If your migration is to move the data around as quick as possible, don't stop for these things. You may do them later or before, but not at this point. But if the goal of your migration is to get rid of this kind of stuff, okay, but plan it like that. Then we have the option of extending Hadoop, okay? All of the previous attempts that we talked about, of the three methods, the classical UNIX methods, the Amazon S3, and the DCP, were like jumping from one branch to the other, like the squirrel does. Or in the case of DCP, it would be more like a locust swarm, something like that, because there are many. But basically, it's jumping from one place to the other. Okay? Why don't we do like the caterpillar? Why the caterpillar? Basically, because if a caterpillar is moving through on a branch, and then reaches a point where it wants to go to the other, it will not jump. It will just, keep a firm grasp with the back paws, and then extend its paws to the new one. Okay, and it's not until the new branch is firmly grasped that it will let go of the old one. Okay, so at some point it will be between both. That's something that we may try to emulate here. Let's see how. What's the procedure for extending? Very similar to the old ones. I mean, just install some software, copy the data, install more software, okay, copy the data. Remember that copy the data used to be somewhere between 0.4 and 0.5, between stopping and starting the new platform? Now we've moved it elsewhere, okay? So, what's the point here, basically? Since copying the data was what took most of the time, we want to take it outside of this equation, okay? We want to we want to plan a migration that's as easy and transparent as possible. So we just put all the complicated procedures here in the 4 and 5 points, and then the copy we want to do while the cluster is running, okay? So we don't want to have downtime for that, okay? Is it possible? I mean, because we talked about there were some data consistency issues. We'll see that it is, okay? But except for that, it's very similar to the others. So, installation. We just go and install something. We have a new platform. We install servers, okay? Keep in mind that we're not talking about installing a new cluster here. So, this is why we break all this part down. There's a first step where we install those servers. Of course, we need to have enough to hold all data because we're copying that from the original platform. You may not, move to a point where you don't have enough space. They need to have the same operating system and configuration as the original platform. So of course, it's very useful if you already have deployed in your organization something like Puppet, Chef, Ansible, and then you just, bake new servers as needed. You need to set up connectivity, same as we did with HDFS. You still need private networks from one side to be available from the other, okay? So make sure you do that. Also the DNS. So basically anything networking, just have it centralized. And then you need to have consistent times and time zones. Okay, this is something that if you forget, it will bite you back at some point. What do you end up with? You end up with one Hadoop cluster on one side, a VPN, so the network is available, but on the other side, you just have a bunch of servers. Okay, so they are not doing anything at the moment. So, what do we do with them? We take the ones that are going to have a storage type of servers, okay, and we install the data node role on them, just the data node role. No computing yet, okay? We don't deploy yet Yarn, Impala, whatever you may have on top, okay? Remember that we're focusing first on just copying the data around, just moving files. Data nodes will be initially inactive, okay? You just install them, they are lying around. Very important, rack-aware configuration. This is how we control the way that the data is going to be copied, okay? So it's very important that new nodes are set up, or you tell the cluster in whatever manner you have, that they are on a different track than the old ones. And you should end up with something similar to this. Now the cluster is, a little bit extended. It has some pause on the new platform, but it's still not there yet. Okay. Very important. Remember, we said keep in mind the VPN. If someone forgets the VPN and just, I mean, we've tried. Just add the DNS entries. You have two DNSs. One on one side has some private networking and public for the other machines, something like that. It won't work, basically, because the nodes, when connecting, they advertise their own internal IP address. Okay? So you would get this kind of errors that some data nodes are not reachable. They never, get to send a heartbeat to the name node. If you do have the VPN okay, it will show up, just like the rest, working normally and available. So everything's ready. We have everything. Go. Okay, how do we go? We just start the data nodes. There's a very important distinction over here, okay? If you have all the original data nodes in the same rack, remember the rack-aware configuration, okay, we're not talking about physical racks here, the copy process will begin immediately, as soon as you start the data nodes, okay? If you have more than one rack in your original platform, for whatever reason, okay, you need to do some changes there. You either need to move them to one rack, and then we can proceed like step one, or you need to do something else, like temporarily increasing the replication factor, something like that, okay? We're counting, but basically it will be patching to get to point one, okay? So for whatever reason, we want to, as soon as we start data nodes, begin copying, okay? When we do this, the service will still be available, okay? So you will still be able to submit new tables, ingest data, do reporting. This is what you see on the new data nodes, okay? This is the log file for one of the data nodes. It will start, it will, provide all this general information. It will, become integrated in the cluster, and at some point, it will begin receiving blocks from the other side, okay? And you will see that there in the part that's in bold, receiving one of the blocks from one of the IP addresses located on the other side of the network, okay? Errors. As soon as you do this, you will begin to have, these red pilots everywhere. Okay, so where did it go wrong? Nowhere, okay? The name node detects that the data is misplaced, okay? This is, this is what we intended to do anyway, because this is how we make, or how we force that data is copied to the other new data nodes, okay? But at some point, it will mark the beginning of, that something, it's not broken, data's still there, but it's just not the right way, okay? And the cluster will begin to moving in that direction to make sure that you have, copies everywhere. But monitoring, or if you're on HDFS FSCK, you will have these kind of errors. You will see, for example, over there that the placement, the replica placement is violated, and you will see that there are misreplicated blocks, okay? They will probably never be 100%, because remember that the replication factor is per file, so you probably just have some files lying around that are, replication factor 1 and are sitting there on the original platform. But the rest of them, they will begin getting copied to the new platform. Okay, the copy begins. And then how do we detect this? This is the graph of the HDFS input-output, okay? So at some point, okay, this was done on a test cluster, so of course there was not much activity at the very beginning. But as soon as you start these new data nodes, you will see the network transfer spike to a certain point, and then keep constant, okay? First of all, this is good. You will be able to detect that the migration is ongoing. And also, since you will have a stable value at which the copy is taking place, you will be able to, predict at which point the copy will finish. Okay, so let's say at the very beginning we said, okay, you had 20 terabytes to copy. You're going at 10 megabytes per second, 2.5 days. So you may, predict when that's going to happen. You may even alter the transfer speed using these two parameters over here, okay? the bandwidth per second for each data node, and the multiplier for the replication of the data node, okay? The first one is just the bandwidth used by each data node, and the second one is the amount of blocks that should be copied in each heartbeat that the name node sends, okay? One concern here, are we using our bandwidth correctly? I mean, after all, we know that Hadoop cluster has lots of internal connections, in between, and sends data from one side to the other. We all see that it's never quiet inside a Hadoop network. There's always some, background noise. But keep in mind that here, we don't have yet any computing roles on the other location. So we may get some remote HDFS, client petitions, but no jobs are being launched here. So it's not the main concern of these new servers that we installed. So data flow is almost exclusive to the copy, okay? So even if you're, just adding files to the other location, this will get copied here, but they will not become part of the operation of the cluster, of the, the jobs that are getting launched and things like that. Not in a significant, statistically significant way. Okay, we need to add still more components. So yeah, now the copy is ongoing, but what about the computing? At some point we will need that, for sure. Let's just begin installing the missing roles. The node manager, the Impala daemon, these roles need to be stopped at first, okay? Why? To prevent this condition that we said. What about master roles? One possible, you just have to migrate something. You just push them also to the other side. How do you do that? If possible, just take advantage of the high availability. Zookeeper, just add 2 more nodes to the new platform. The name node, just get rid of the standby node and move it to the new platform as well. Same with the resource manager. Some of these services you will not be able to migrate so easily, okay? The Hive Metastore DB, for example, if you haven't got it replicated on both sides of the cluster, you will need to copy that using the traditional UNIX methods. For all these kind of things, external services, having a DNS that you can, point to one place or the other, of course, it's always useful. You also need to install the rest of auxiliary servers. If you have something that ingests the data, that copies the data around, that even, BA tools, web services, application servers that go with the Hadoop cluster, you will probably need to copy them as well. Of course, that's completely outside the Hadoop core, so you will need to do them in whatever fashion you deem convenient. You will end up with something like this. Basically, now we have a Hadoop cluster that's running on both sides of the network, okay? And it has enough roles on both sides to be able to function normally, okay? Remember that on the new side, there's no computing yet, it's still stopped, okay? So, what do we do now? Copies in progress, additional software is in place, we have all the auxiliary services. We just wait for the copy to finish. We said we were able to predict it, also do a middle check just in case. And we plan a final intervention where we will, end this movement. How do we go on with that? First of all, it's similar to what we did before. We stop the cluster. If necessary, remember that we've been deploying new roles all over the place, so if needed, redeploy the client configuration and begin starting services, okay? Start with Zookeeper, then go ahead with HDFS on both sides. We'll see why. You start Yarn, but only on the new platform. And if you have something like Impala, start it only in the new platform as well. And then start auxiliary services and, of course, test them. Everything's okay, everything's running. The results match what was expected. Okay, change the DNS entry points. Here is where you finally, remember on this procedure, we do have downtime, okay, so it's not perfect. We do have downtime, the cluster is stopped, but now you point via the DNS everybody to the new location, okay? At this point, we have switched the roles of the two platforms. Remember that we had one that was computing and the other was still just storage. We've just reverted. We have minimal downtime. It's very similar to other Hadoop works, non-Hadoop works, sorry, the UNIX ones. Data is never at risk. We always have a copy on both sides. There's no user impact because we have the same cluster, so nothing's changed. Even the very picky users won't be able to find a difference because there isn't. And Kerberos is not an issue either because you are on the same realm. It's the same platform. Disadvantages, of course, it took some slides to show, so it's a complex procedure. You may not want to do this every time. So what's the final picture? Okay, great ideas started in the garage. You want to, get from something old and, I don't know, not well designed to something that's, more polished. So that's what we just did. With all of the methods described here, okay, you have to pick whatever's more suitable for you. You will begin with one service on some side, and then you will end up with all the cluster being installed on the other, okay? So at the point where you are confident that you will not need to roll back to the old platform, you may just turn them down and get going with your, new and shiny life. Thank you. So that's basically it. I don't know if there are any questions.
Hi, thanks for the presentation. I got a few questions. First one is, when talking about this CP and the metadata, have you considered using an Apache project whose name is Falcon that takes care about the metadata? And the second question is, what about the impact in your last solutions when you, every time you write a new file on HDFS, it needs to be also copied to the other cluster, to the other side. So maybe there is kind of latencies in your copy stream. And also with zookeepers, that is very slow latency. If you just add 2 new zookeepers to the other side, what is the impact when you did that?
Okay. First of all, about using Apache Falcon, no, we haven't done it. It's on the queue of things to investigate. I know that there are some projects related to that, but with all the installations that we've run through, they didn't have Apache Falcon, so we didn't just use it. We just went for the manual approach. But I mean, this is an ongoing ecosystem, so of course, hopefully, but at some point you will need to do this by hand. Secondly, as you said, the new files that are being written on the active platform. Of course, as you said, this will need to be copied to the new platform as well. That's part of the copy. I mean, even if they just sat at some point on the initial platform, and you need to copy them to the final destination, of course, you need to make sure that that data arrives at some point. So it will just get into the flow with the rest of the other things. If you don't tune the transfer parameters so that you have a bottleneck in the VPN, and remember that right now service is still being available, so you don't need to do that. You just you will get the copy normally, and you shouldn't have much impact on the writing on the HDFS writes. Okay. And about Zookeeper, remember that Zookeeper and the rest of the services, I know that they are critical, so that's why we implemented this to the end. Remember that we are talking about letting the copy go, okay, still everything's running on the first cluster, and at some point you just need to test things in between. So the window where the control is balanced between both networks should be small. Okay, I would even suggest going for degraded mode for some of the services, so they are running just on one side of the cluster or something similar, to avoid this kind of stuff. I mean, having to copy that control data around. So just try to keep that at a minimum. Okay, if you don't want, you don't need to start them until the intervention. So you just go ahead with all the planned work, have all the data copied, and then just switch on the new zookeepers. Okay, so you don't even have to have the HDFS copying background noise for that. Okay. Any other questions? No? Well, thank you very much.